Welcome to the second part of our series of section-wise analysis of the College Board's official practice test papers. In the previous video, I explained the number of questions from each topics. I have divided the questions in these 30 categories, and we did an analysis of how many questions were there from each category in each test. And we came to a conclusion that there were maximum number of questions were from the topic of quadratics. I think quadratics is the most important topic because it has at least 4 questions in each test. So let's start from quadratics. And in quadratics, these are the question types that you can expect. First is finding minimum value from equation, finding minimum value from graph. So they can give you the equation of a quadratic function or just a quadratic equation. And from that equation, you have to find out, either you have to find out the minimum value, or you have to find out the value of x at which the function or equation will take its minimum value. And then you have solving quadratic equations, very basic. Then system of quadratic and linear equations. This is the topic from which you can expect minimum 1 question from this. Then sum and product of solutions. Then number of solutions of a quadratic equation. And then finally, we have HOTS. HOTS stand for higher order thinking skills. I saw that there were some questions which did not fall into any of these categories, and they just involve a lot of critical thinking, and you can solve those questions only if you have 100% conceptual clarity. There are some long word problems, and they require very, very deep understanding of quadratics. So let's get started from the first category, which is finding minimum value from equation. So we have 2 questions. First is this. In this one, we have a quadratic function, and it says for what value of x does f of x reach its minimum? And we have a similar question. Here we have a quadratic equation, and it says for what value of x does the value of y reach its minimum? Both the questions are actually same. We have to find out the value of x for which the equation takes minimum value. Now there are 2 ways of solving these type of questions. First is you can do it algebraically, or you can also do it on DESMOS. I would recommend that you should do it on DESMOS, because if you do it on DESMOS, you won't make any mistake. Well, unless you make a typo. Okay, so just make sure that you're not making any typos when you are typing the equation on DESMOS. Okay, first let's discuss how to do it algebraically. So whenever you have a quadratic equation or a quadratic function or even a quadratic expression, you have to compare it with the standard form. So the standard form is ax squared. Standard form of a quadratic expression is ax squared plus bx plus c. You compare it with the standard form, and you find out, if you compare it, find out the values of a and b. You don't need the value of c, just find out the value of a and b. So a here is 1 and b is -14. And once you have this, then the value of x at which y will reach its minimum, that value is given by -b over 2a. So all you have to do is put the values of a and b into this formula. So now be careful, it says -b, and b is already negative. So it will be negative of -14 over 2a. So positive 14 over 2, which is 7. So when x is equal to 7, then y will take its minimum value. Now, be careful, this question is not asking to find out the minimum value. It is asking to find out the value of x at which the function will take its minimum value. Now, this is how you can do it algebraically. And the same question if you have to do it on DESMOS, which I would recommend. So for that, all you have to do is you plot this equation on DESMOS. So you have to open your DESMOS. Let's get rid of all of this. Type the equation y is equal to x squared minus 14x plus 22. Okay, and it will give you the graph. Now, obviously, the minimum value will be at the vertex, right? So you click on the vertex. You need to zoom in. Click on the vertex. Now, the vertex is 7, negative 27. So the minimum value that this equation takes is this. This is the minimum value. And the value of x at which it will take the minimum value, that's 7. So your answer will be 7. And that's what we got using the formula negative b over 2a. Now, in this case, this was an upward opening parabola because coefficient of x square is positive. If coefficient of x square becomes negative, then the parabola will become downward opening parabola. In that case, you don't find out the minimum value, you will find out the maximum value. And that will be again given by the vertex. So if instead of x square, I make it negative x square. So see, it will flip. And in this case, they can ask you either what is the maximum value or the value of x at which the function take its maximum value. So this time the answer will be negative 7. And if you get this question from, like if you have to find out the minimum value from a graph, or you have to find out the value of x at which it will become minimum from graph, then also it's very easy. You just have to see the vertex. In either case, you just have to look at the vertex. The vertex will give you the minimum value. It will also give you the value of x at which the function will take the minimum or maximum value. Now, the next question type is solving quadratic equations, which is the third question type. In these question types, well, these are the easiest. You will have a quadratic equation. So this is a quadratic equation, and you just have to find out its solutions. If we see another question, here also we have a quadratic equation, and its solution is, it can be written in the form 1 plus square root of k. So what is the value of k? Next question, this is very simple. What is the solution to the given equation? Now, all of these questions you can do, again, you can do them either algebraically or you can do them on DESMOS. And if you want to do them algebraically, there are 3 methods to solve a quadratic equation. You can either solve it using the quadratic formula, or you can solve it by factoring, which is also called the AC method. It is also known as splitting the middle term. So if this method applies, that you can solve the equation using this method. And another method is you can use special patterns. Okay, and if not algebraically, then you can always use DESMOS to solve any quadratic equation. All you have to do is you have to plot the equation on DESMOS. So now don't type this equation as it is because DESMOS won't understand what's z, right? You have to type y is equal to x square plus 10x minus 24 on DESMOS. Okay, and then you just have to see at which point or at which points the parabola is touching or intersecting the x-axis. Similarly, you can do this question here. This is slightly different. Here it says one solution to the given equation can be written as 1 plus square root of k. Okay, so if you plot it on DESMOS, x square minus 2x minus 9, let's plot it on DESMOS. So y is equal to x square minus 2x minus 9. Let's zoom out. So this is the parabola. And we have 2 solutions. It is crossing the x-axis at 2 points. This is the first point, and this is the other point. And they say that one of the solutions can be written in the form 1 plus square root of k. Okay. All right. Now, obviously, your solution, you have 2 solutions, right? 4.16228 and this. Okay. Now, this number, whatever is 1 plus square root of k, it cannot be negative because square root of k, whatever is the value of k, it cannot be negative, right? So the solution, they are actually talking about the positive solution. So you take 1 plus square root of k, you put it equal to this solution, the positive solution, so 4.16228. And you have to find out the value of k. So square root of k is equal to this number minus 1. So that will give you 3.16228. So k, now you can square this equation and you'll get k is equal to square of this number. So taking square both sides. And it looks like it will give us approximately 10. Value of k should be 10. And from all the answer choices, see, square of this number 3.16228 will be more than 9. It will be very close to 10. It can definitely not be 8. It cannot be 20. It cannot be 40. It will be 10. You don't even need your calculator. Okay. Then we have this question. This is a very easy question. I think I don't even need to discuss it. To solve this equation, just multiply both sides by 25 and you'll get x squared is equal to 36 times 25. That will be 900. Next type of questions from quadratics is sum and product of solutions. Now, in the 6 practice tests, there was only one question based on this concept, based on sum and product of solutions. But if you will see the previous SAT question papers, if you'll see from 2015 to 2020, you will see there are many questions based on the concept of sum and product of solutions. And it is becoming increasingly popular. Now, there are many ways to find out the sum and product of solutions of a quadratic equation. First way is, and most of the students do it using the first method, and which will take a lot of your time. Students will first find out the solutions. So they will solve the equation. That means they will find out the solutions and then add them to get the sum or multiply them to get the product. And other way is that they will find out the solutions using DESMOS and then you will add them. That's smarter than the first way. And the smartest way is, if you're the smartest person, then you will use the formula for sum and product. Sum of the solution of a quadratic equation is given by negative b over 2a. And product of the solutions of a quadratic equation is given by c over a. Now, oh wait, this is not negative b over 2a. This is just negative b over a. And you have to be really careful. Negative b over 2a is the x coordinate of the vertex. Do not confuse these two formulas. This is x coordinate of the vertex of the parabola. But sum of the solutions will be negative b over a. And what are a, b, and c? Well, you have to compare the given quadratic equation with the standard form, ax squared plus bx plus c. Now, right now, this is not in the standard form, so you need to just simplify it a bit. So distribute the x, you'll get x squared plus x minus 56 equals to 4x squared minus 28x. Okay, so 4x squared minus x squared will be 3x squared. Minus 28x minus x will be minus 29x. And plus 56 is equal to 0. Okay, so now comparing it with the standard form, we have a as 3, b is negative 29, and c is 56. Okay, and in this question, we have to find out the sum of the solutions. So sum will be negative b, so negative of b, that means 29, and over a, which is 3. So this is the sum of the solutions. And let me just check if we did everything right. X squared plus x minus 56 equals to 4x squared minus 28x. 4x squared minus x squared will be 3x squared. And then minus 28x minus x will be, minus 29x plus 56. So sum of the solutions will be 29 over 3. That's how you can do the problems based on the sum and product. If you have to find a product, you just find out c over a. Next question type from quadratics is number of solutions. So first is a very straightforward question in which they just give you a quadratic equation and they ask you how many distinct real solutions does the given equation have. This is the first question type from number of solutions. Then this is another question type. In this, they will give you that this equation has, like how many solutions this equation has. And then we have to find out the value of some missing constant. The next question is also similar. In this one, they have given that this equation has exactly one solution, and we have to find out the value of this missing constant. So two type of questions from number of solutions. So let's review the concept. If you have a quadratic equation and you want to find out its number of solutions, so you can do it either algebraically or you can do it on DESMOS. You can do it manually or algebraically, and you can do it on DESMOS. So if you want to do it algebraically, so see, an equation can have either two distinct real solutions, it can have only one distinct and real solution, or it can have zero distinct and real solutions. Now, whether it will have two, one, or zero solutions, that depends on a quantity d, which is called discriminant, and it is defined as b square minus 4ac. Okay, so first you have to compare. So whatever your quadratic equation is, you will compare it with the standard form, ax squared plus bx plus c. You will find out the values of a, b, and c, and then you will find out the discriminant. And now, if your discriminant comes positive, then the equation will have two distinct real solutions. If your discriminant is equal to 0, then it will have one distinct real solution. And if it is negative, then it will have zero distinct real solutions. So let's go back to the questions. So in this case, actually first we will do this question. So in this case, we have to find out the number of distinct real solutions. So you compare it with ax squared plus bx plus c equals to 0. So a is 5, b is 10, and c is 16. You find out the discriminant, b squared minus 4ac. That gives you 10 squared minus 4 times 5 times 16. That's 100 minus 4 times 5 is 20. 20 times 16 will be 320. Now, 100 minus 320 will be obviously negative. So that means this equation will have zero distinct real solutions. Now, you can do the same question on DESMOS as well, and I would recommend that you do it on DESMOS. What you have to do is you have to plot the graph. Simple. You have to plot this equation, y is equal to 5x squared plus 10x plus 16. And then you have to see whether that equation, so you have to see, so obviously its graph will be a parabola. You just have to see whether that parabola touches the x-axis. If it touches the x-axis at one point, then it will have one distinct real solution. If it intersects the x-axis at 2 points, then it will have two distinct real solutions. And if it does not touch the x-axis at all, then it will have zero distinct real solutions. So let's go to DESMOS. Plot the equation y is equal to 5x squared plus 10x plus 16. Oh, that's plus 16. Now see, this parabola is above the x-axis. That means it is not touching or intersecting the x-axis. So that means it will have zero distinct real solutions. Next question, the second type. In these two questions, they have given the number of solutions and you have to find out a missing constant. So for example, in this one, this equation has exactly one solution. And we have to find out the value of c. Again, you can do these type of questions either manually or on DESMOS. If you have to do it manually, you just have to find out the discriminant and apply the condition. So when the equation has exactly one solution, then discriminant is equal to 0. So you find out the discriminant, you will get an equation in C and you put it equal to 0 and you'll find out the value of C. And how will you do it on DESMOS? Well, again, you plot the equation on DESMOS. Plot it, y is equal to negative 9x squared plus 30x plus c. Y is equal to negative 9x squared plus 30x plus c. That's the equation, right? Yeah. Now, it does not give you any graph because DESMOS doesn't know what is c. DESMOS only knows what is y and x, And if you click on this exclamation mark, it says too many variables, try defining C. It doesn't know what C is. And it gives you an option of adding a slider. So you click on this blue button, then it gives you a slider from -10 to 10. And you can change the values of C from -10 to 10. And you have to adjust the value of C such that the equation has exactly one solution. And when the equation has exactly one solution, in that case, the graph, the parabola will just touch the x-axis. So it should be like this. It should just touch the x-axis. Okay. So now if I'm adjusting the values of C from -10 to 10, my parabola is not going down, right? So you can change the range from -10 to 10. You can change it to whatever you want. So if you do it negative, what are the answer choices? The answer choices are, okay, let's make it -60 to 60 because that range will include all the answer choices. Okay, so -60 to 60. Let's make the range -60 to 60. And now adjust the values of C. Okay, adjust it. Yeah, it should just touch the x-axis. See, now just to be 100% sure, just zoom in, zoom in, zoom in, zoom in. Sometimes it happens that it is intersecting, but we feel like it is touching. But zoom in enough to be 100% sure that it is touching the x-axis. Okay, so this value, see, this is not the answer. This is not the value of C. Value of C is this, -25. So when you take C is equal to -25, then the parabola will touch the x-axis, and then it will have exactly one real solution. And the next question type from quadratics is system of linear and quadratic equations. And this is the most important question type from quadratics. You can expect one question from this question type. And in these questions, so there were 5 questions from system of linear and quadratic equations in the 6 practice tests. And all of these questions can be done either algebraically or using DESMOS. And in these questions, again, you have 2 question types. One is that they will give you a linear equation, so y is equal to mx plus b, and they will give you a quadratic equation, so y is equal to ax squared plus bx plus c. And you will have to identify the number of solutions that this system will have. Now, you must know that quadratic equation's graph is a parabola, and y is equal to mx plus b is a straight line. So the number of solutions will depend on at how many points this line and the parabola are intersecting. For example, in this case, the line and the parabola, they're intersecting at 2 points. So in this case, the system has 2 distinct solutions, right? The other possibility is that the parabola and the line can touch at exactly 1 point. So in this case, the system will have just one solution. And the other possibility is, you guessed it, yes, that they might not touch at all. In this case, you will have 0 solutions. So one question type is that they can straightforward give you the equation of the line and equation of the parabola, and you just have to find out how many solutions that system has. The second question type is this one, in which they will give you that the system, they intersect. See, in this question, this parabola and the line, they intersect at exactly 1 point, and we have to find out the value of C. Okay, let's see the next question. This is exactly similar. You have a line and you have a parabola, and it says that the system has exactly one distinct real solution. We have to find out the value of A. So they can give you the number of solutions, and you will have to find out the value of a missing variable. In this one, you have to find out what is the possible value of X. Well, this is actually very easy. Y is equal to 76 is just a horizontal line, and you just have to check some possible solutions. We will do all these questions on DESMOS. This is also exactly similar to the previous one. This time, this will be a vertical line. And then you have a quadratic equation and a linear equation. And the system, they intersect at exactly 1 point. What is the value of X? I think this is a mistake. It should be, what is the value of A? Let's see, what do we have next? Okay, this was the last question. Now, how do you solve these type of questions? So I'll tell you both the methods. First is you can do them algebraically. You have to equate them. So y is equal to this, y is equal to this. You just have to put them equal to each other. Minus 100 is equal to c. And then you have to convert it into the standard form. So negative x squared plus 9x minus 100. The c is a constant, bring it on the left side, minus c is equal to 0. Now, if you compare it with the standard form, so ax squared plus bx plus c. So you get a is negative 1, b is 9, and c is negative 100 minus c. Well, instead of c, you can take another variable d. So, no, not d. Actually, let's keep it c only. Now, it's given that the system has exactly one solution. So what you will do is you will just apply the method of discriminant. You find out the discriminant by doing b square minus 4ac. But now you will find out the discriminant of this new equation. Now, this is a new quadratic equation. You will find out the discriminant by using these values, okay? So b square will give you 81, 9 square, minus 4 times a is negative 1, and c is, well, c is negative 100 minus c. And since it has one solution, so your discriminant is equal to 0. And from there, you can solve for c. Okay, just put this equation equal to 0 and you can find out the value of c. Now, you can also do these type of questions on DESMOS. Plot the parabola, plot the equation, and put a slider and adjust the slider such that the line and parabola just touch at exactly one point, okay? Because in this case, this system has one distinct real solution. So let's plot it on DESMOS. So our equations are y is equal to negative 1.5. That will be a horizontal line. And the parabola is x square plus 8x plus a. X square plus 8x plus a. Now add the slider. So you have your parabola and the line, and you want your parabola to touch the line at exactly one point. So you adjust the slider. And, look at the answer choices. Oh, we don't have the answer choices. So see, right now it is not touching the red line. So you need to change the interval from negative 10 to 10. I'm going to make it negative 20 to 20. Now, okay. 14.3, you can manually type the values, 14.4, 14.5. Looks like it is touching the line at 14.5. To be 100% sure, you need to zoom in. Yeah, just zoom in, keep zooming in. It is touching the line when a is equal to 14.5. So the answer will be 14.5. And if you have a question in which you just have to find out the number of solutions, you just plot the equation of the line and the quadratic equation and just see at how many points they are intersecting. Now, the next question type, I have given these question types the name HOTS. HOTS is higher order thinking skills, and some word problems. Now, I saw a word problem in one of the tests, and there are similar word problems available on College Board's official practice questions. So these problems are really easy. They will give you, okay, so let's read it. An object is kicked from a platform. The equation, this represents this situation where h is the height of the object above the ground in meters, t seconds after it is kicked. So you have a platform. This is a platform. Okay, and h is the height of the object above the ground. Now, there is an object on this platform. Okay, and you are kicking this object. You kick it. And so when you kick something, it follows a quadratic path. Okay, so it will kind of follow this path, which is a parabola. A second. Okay, and so the equation of this parabola is given by negative 4.9 t square plus 7t plus 9. So this is the height of the object t seconds after it is kicked. Which number represents the height in meters from which the object was kicked? Now, this object was kept on this platform, right? And we have to find out the height from which the object was kicked. So when it was kept on the platform, the value of t was 0, okay? Because we have to find out the height from which it was kicked. So when you kicked it, at that moment, the time was equal to 0. So you have to find out the value of h when t is equal to 0. So you put t is equal to 0 in this equation, okay? And then you will get h is equal to 9. So answer choice D will be correct. Then there are some questions which don't fall into any category. There you have to apply concepts. The more deeper your concepts are, you'll be able to do these questions better. But I have seen that these questions can be actually solved easily if you know how to convert a quadratic equation from standard form to factored form to the vertex form. If you know these three forms well, and you can convert any form into another form, you will be able to do these questions. For example, here we see that this expression can be written as this, where h, k, and j are integer constants. Which of the following must be an integer? Now, this problem stumps out every student. None of my students have been able to solve this problem. And if you really think about it, this expression is actually in standard form, and this expression is in factored form. So in order to find out which of the following must be an integer, what you can really do in this question is you can just do one thing. You take this hx plus k, the factored form, and you convert it into standard form by multiplying these two factors. So hx times x, hx square plus hxj plus kx plus kj. Bring it into the standard form, you get hx square plus hj plus k times x plus kj. Now, since this expression can be rewritten like this, so you compare it with the given expression, 4x square plus bx minus 45. So if you compare the coefficients, you will get h is equal to 4, hj plus k is equal to b, coefficient of x, and then the constant term is kj is equal to negative 45. Okay, now if you really think about it, you have to find out which of these following answer choices must be an integer. Now, h is an integer and value of h is 4. Okay, and if you look answer choice C, it says 45 over h, 45 over 4. Well, that will not be an integer. So C is not correct. And if you look at this, k times j is equal to negative 45. So j will be equal to negative 5 over k. And this is actually very close to answer choice D. It is just negative. And see, it's given in the question that j is an integer constant. So j is an integer. So if j is an integer, then this whole thing has to be an integer. That means this thing has to be an integer. That's it. That's all we can say about this question. So answer choice D will be correct. Now see, in this question, this does not fall into any specific category. This is just random application of all the concepts that you've learned of quadratics. We'll see another question. This is also a challenging problem, I should say. In the xy plane, a parabola has vertex 9, negative 14 and intersects the x-axis at 2 points. If the equation of the parabola is written in the form this, where a, b, and c are constants, which of the following could be the value of a plus b plus c? Now, this problem also stumps all the students. And this is also based on conversion of, here you will have to convert the vertex form into standard form. So if nothing comes to your mind, think about the conversion of the three forms: vertex form, standard form, and the factored form. Okay, now see, in every question of SAT, they will give you, like, each piece of information will be given for a reason. Okay, so you have to make sure that you're using every piece of information. First information that we have is that the parabola has vertex 9, negative 14. Well, this allows us to write the equation of the quadratic in the vertex form. So the vertex form is given by a times x minus h whole square plus k, where h and k are the vertices of, h and k are the coordinates of the vertex. So this is h and this is k. So your equation in the vertex form is y is equal to a times x minus 9 whole square minus 14. And it can be also written in this form, this is the standard form. So you can convert the vertex form into the standard form. So this x minus 9 whole square will be x square minus 18x plus 81 minus 14. Distribute the a, so you get ax square minus 18ax plus 81a minus 14. And that's it, we have it in the standard form. So you compare it with ax square plus bx plus c. So you get the values of a, so coefficient of x square is a, so a is equal to a. Then negative 18a is equal to b. And 81a minus 14 is equal to c. So you have the values of a, b, and c. See, we didn't even have to think about how we will find out the value of a plus b plus c. We just started writing the vertex form and we converted vertex form to the standard form, and you have the values of a, b, and c. So you put these values into this expression, a plus b plus c. So a is just a, b is negative 18a, and c is 81a minus 14. Okay, so if you simplify the expression, you'll get a minus 18a plus 81a minus 14. And 81a plus a is 82a. 82a minus 18 will give you 12 minus 8 is 4. And so 64a minus 14. Now you have to identify which of the following could be the value of a plus b plus c. And we have reduced a plus b plus c to this. So 64a minus 14 can be equal to which of the following options? Can it be equal to negative 23? Can it be equal to negative 19? Can it be equal to negative 14 or negative 12? Now, I mentioned at the beginning, now just pause the video and think about it. How will you figure out that 64a minus 14 will be equal to what? So I mentioned at the beginning that they will not give you any information without a reason. And so far we have used all the pieces of information except this, that the parabola intersects the x-axis at 2 points. We have not used this information yet. Now see, this is a very important piece of information. See, this parabola has vertex 9, negative 14. So 9, negative 14 will be in the fourth quadrant. So this has vertex of the parabola is in the fourth quadrant. So it can be either this or it can be either this, right? But it says that it intersects the x-axis at 2 points. Now, if it is downward opening, if it is this, so it will never intersect the x-axis, right? If it has to intersect the x-axis, then it has to be upward opening parabola. And if it is an upward opening parabola, that means a has to be greater than 0. And that's what you need to figure out, okay? So if 64a minus 14 is equal to negative 23, solve it for a and see if you get a as a positive number. This will not give you positive. 64a will be equal to negative 23 plus 14. This will be a negative number. So a will be a negative number, okay? And if you see all the answer choices, you will realize that when a is equal to negative 12, I'm sorry, if 64a minus 14 is negative 12, then only a will be positive. So 64a minus 14, if it is equal to negative 12, so 64a is equal to negative 12 plus 14. This will be a positive number. 14 minus 12 is 2. So a will be equal to 2 over 64, which is a positive number. So answer choice D will be correct. So if you see this question, just it's not a part of any specific question type. Instead, here you had to apply a lot of concepts. You had to apply the vertex form, the standard form, and you should know that if it is an upward opening parabola, a should be greater than 0. A lot of concepts were applied here. So this was a really conceptual problem, and you can expect these type of problems in module 2. And don't worry, these type of problems you'll be able to figure out by more and more practice. And if you find these videos helpful, don't forget to give a like and please subscribe so that you don't miss the next videos. And in the next part of this series, we will take another topic. This was on quadratics. We will take the next topic. Most probably, we will take linear equations because many questions are asked from linear equation, linear functions. So stay tuned and thank you for watching.